Again? Tackle? Whoa. Don't do that. Okay, hi. My name is Tim Rüsen, maybe unpronounceable to non-Germans. I'm a maintainer of GNU wget and of, well, libIDN and IDN2 and some other stuff. We are working in a small team on wget 2 since a few years. And during this work, it turned out that we moved a lot of code into a library called libwget now. Well, of course, this is mainly contained so far code that we use in wget 2, but I think lots of this code is usable for others as well. And, well, this is just a small introduction for you if you are a maintainer or programmer or something doing like this, just to show you that we have something like this. And this is just a small introduction with some examples. And I would like to, maybe like in 20 minutes or so, we can then go into hacking. We are currently 3, but later 4 maintainers of wget, so everybody's here. And we can go into hacking with you or answer detailed questions. I don't want to bother you with all these gory details, so I just make a small overview with examples. So you get an idea what we did, what it is all about, and how you possibly can use it if your application is a web client, an HTTP web client in a broader sense. So it's more and more common that files are on the internet, and a lot of people are coding their own stuff, their own network stuff, so you don't have to do this anymore. We have several layers of networking, HTTP, parsing, everything, the algorithms that you need, like hash maps, vectors, this is global arrays, lists, and all this stuff. We export everything of it. So, well, once you go into it, I guess you can find a lot of useful stuff that you can, that you don't have to maintain in the future. That's the idea. We maintain it for you. So, just an overview. It's an HTTPS client library. It's LGPL3. So everybody with a GPL2 only application is out. Go out. Everybody else should be fine with the LGPL3. We use all this code. Our code is backed up by GNU-lib, so we are very portable. It's just a layer on top of it, so you don't have to go into the gory details of GNU-lib or something. If you use system stuff internally, it's backed up. So, you can just use libwget without getting into GNU-lib dependencies, whatever. But it depends on the project, of course. So, sure. We do, since a long time, we do continuously, testing is not enough. We have like 12 runners, so with every commit, we tested on all kinds of architectures and everything, so we know it's working. We have unit tests, of course, functionality tests. We have continuous fuzzing on Google's OSS Fuzz platform. Of course, we found a lot of things there, but they are all fixed. So, we have FreeBSD, Minji, we use here, you can see it here, OS X. We use Travis CI for that. If this tells you something, it's a service that provides continuous integration also with OS X. Everything, of course, with sanitizers, address sanitizers. What you need for, to make sure that your C program doesn't behave in a funny way. Have a very good code coverage, test code coverage, and what I'm working currently on is I separated the somehow bigger libwget into very many smaller libraries. You can use it in the future. It's already it's still in a separate branch now, but in the future it will come. And so far, you can make or in that case, once it's in master, you can make very small executables. We will come to this soon. Yeah, and we have a C API, so you can use it for everywhere. Next page here. This is an overview about the most important functionality groups that we provide an API for. So first of all, TCP/IP networking, of course. You can just open a connection. You have, well, we go to the examples later. So we have DNS caching, so we have an own caching mechanism. You can turn it on and off if you want, something like this. Just don't use it if you don't want it. We have currently the GNU TLS backend as TLS backend. This is the main thing where we support all this fancy stuff. OCSP, for example, this is like certificate revocation things. HPKP, this is, no, we don't do this.
We do it, it needs to go out.
Huh?
It needs to go.
No, we do it pretty well.
We do it, but nobody uses it.
Nobody uses it, of course. That's a feature. But, well, anyways. Okay, very recently we did some Wolf SSL implementation. If somebody is interested, it's mainly for embedded devices. OpenSSL just got in, I don't know, last week, worked on it. And, well, we have HTTP, HTTP2 protocols. This is transparent. You don't even see that you are using it. You can enable or disable it so you have full control, but you don't have to care about the gory details. We have several decompression stuff we talked about yesterday. The LZIP. Antonio was your name, right? Antonio. So LZIP is missing here, but, well, as soon as you talk with Iana and maybe get it in, I would like to see it here as well, of course. We have all this parsing stuff, .NET RC database parsing. For example, who's using it anymore? Not many applications, but if you use it, if you ever access .NET RC, oh, you do it? Okay.
Yes, I use it on a regular basis.
Okay, you have an API for it. You can easily access it. We have a XML scanner. Well, the low-level part is a tokenizer. The next one is a scanner, which is more or less a callback function. And it's not a parser that gives you something like a document object model fully parsed in memory. So this completely XML and HTML stuff works without memory allocations. Completely. It just gives you callbacks and say, okay, I've found the next attribute, here are the values and stuff like that. So you could build a DOM, but we don't need it in wget 2, so there's nothing. But if you want to use it, it's very short and I think very fast. And you don't have this bloat like libxml2, for example. Sometimes you just need a scanner to parse out, well, several pieces out of an XML file, for example, or from an HTML file. What we use it for, of course, is metalink is XML. Of course, the HTML pages, web pages are mostly HTML. So we scan for recursive downloading. You know, wget can only download single files, so you can say, give me the whole web page. So we have to scan the HTML files for URLs, links, and we download everything into a directory, a subdirectory, and everything. So you can basically have a mirror of your website. Well, we have for ATEM RSS scanner. This is XML based. We have all kinds of hashing, you know, this digest hashings like SHA-256, for example, or whatever, MD5. Very convenient functions that make it really easy. We have several backends here. First of all, if you build with GNU TLS, you use the GNU TLS hashing functions, of course, internally. If you don't have TLS at all, you can build wget without TLS. Then we use Nettle. Nettle is, well, just a crypto library, a standalone crypto library. We have, well, if you build with Wolf SSL, we try to get the crypto from there, or we'll use Libget crypt. We have OpenSSL crypt as well, right? Under you implemented the crypto functions for OpenSSL. It's missing here, okay. And if you build without all this stuff, then we have still these functions in GNU-lib, so you can be sure that it's all working. We have CSS parsing, metalink. Does anyone know what metalink is? No, metalink is an XML-based description of a single file, for example, including checksums. So you can do some fancy stuff with it. If you offer a huge file for download and you know that you have a slow connection, somewhere in the middle it breaks or something is broken within the file, metalink allows you an automatically scan and continuation. So you can control C and you can restart the download, and this metalink file has all information chunks, like for file chunks with checksums. So we can just build checksums and see, oh, this part here is missing or broken, we have to re-download it, something like this. Metalink is pretty cool, but not very widely used. It's also a standard, RFC standard, and I would like to see it everywhere, but, well, nobody is using it very well. Yeah. We have sitemaps, some pages, some websites give us sitemaps with all the files, like news files or whatever. We support all this parsing, robots.txt parsing. Well, it's not so important maybe. Database APR for NetRC cookies, HSTS, APKP, TLS session resumption, if you ever need that. So this is session resumption is to speed up TLS connections a little bit. So OCSP, this is a protocol to check certificate revocations, because, well, you have your CA certificates for TLS on your operating system, but hey, do you know if 1 hour ago the provider disabled them? No, you can't know that. The update cycle is too slow, but OCSP connects to the issuer and asks, hey, is this certificate still valid? And maybe normally they say yes, but sometimes not. We have convenience function for multi-threading, so to make it very easy, and you don't have to care if your program uses p-threads or Windows threads or whatever. You just use the wget threading functions and you're fine. Then you can compile it on Windows, on what backends do we have for threading? p-threads?
P-threads, GNU-lib threads.
Well, everything that GNU-lib offers.
And
Well,
I
hey,
think
basically.
also ISO C11 threads.
C11 threads also, okay. We even have an API for our progress bar, so you can have a multi-line progress bar forever. Whenever you need to do something that takes a little bit longer, you can, well, just use it for displaying. Then we have a lot of basic APIs for lists, hash map, vectors, well, even multi-thread save random, which is not, oops, well, sorry. Well, we have loggers, we have functions for I/O memory strings. You can use it, you don't have to. Okay, example size of the library code. Built with -OS and GCC. This is for size optimization, of course. LD's as needed flag was used. So we have an overall size of 388K for everything that I showed you on the previous page. Plus, that was not all, there's even more. Just for an example, the SO file, so the dynamic library for XML and HTML scanner is just 40K long. The object file size is just 4.2K. So it's really small and it's well tested. It just works. So whenever you want to have small executables on embedded devices or anywhere. The HTTP parser is another example. It's a little bit larger, and URL parsers, including utility functions, is well, also even bigger than an XML and HTML scanner. So now we come to the examples. Normal GET request. We start. Well, do we have a mouse here? Here we have the URL. Just a string. You have to parse it into a convenient form, into a URI. Then you create a request. You can, the next lines are optional, like TCP fast open if you want to use it. You can set it on or off. There's a lot of stuff. It's just examples here. You can say, okay, I want to use TLS false start or session resumption, whatever. You can, we have a lot of things. It's just an example of what you can do. You can set extra headers, which is pretty often done. So, and the next one, I left out the error checking here, so just to show that the core functionality is you do an HTTP open, you get a connection now if everything went well, you send your request. The interesting thing is it works asynchronously. So the open returns immediately, and if you do a send request, so you can do after that something CPU intensive, for example. You send the request then, which also immediately, as soon as the socket is writable, it writes the request and comes immediately back. So you can now do whatever you like. You can do some, well, things in parallel without having multi-threading. And after a while you say, okay, now I'm ready to get the response, and you call the get response, normally a few milliseconds later. And this, of course, has to wait until the response is there, and then it comes back. And you can see, for example, the response has a lot of fields, of course. It's a structure with a lot of fields. Here we just print out the header and the body. You would see the complete response with a single printf. All our buffers are always zero terminated, so you can do things like this. And you never have to care, oh, is this buffer or this string or memory thing, is that zero terminated or not? We make it easy for the programmer not to fall into this stuff. Everything is always zero terminated, so you can use string functions everywhere. Example 2. Yeah, we have an even simpler API. For some cases, this is very easy. This is a complete program here, as you can see, and all you do is say wget http get. So you can, it's a variable argument list. There are a lot of features that you can set. One commented out is you want to have the header going to standard out, for example. You can use callback functions and all this stuff to get all the information. But in this case, we just want to do the get with the URL, example.com index. You get the response back, and you say, well, just print the body data. You can parse it, you can do everything with it as you want, and if you're done, you say free response, that's it. You know, this is not async, but often you have applications where you really have to wait. Well, this is convenient or enough. Interesting. I had a ping time, is it visible here, of 130 milliseconds. This was HTTPS request, so with TLS connection, and it took an overall time of 330 milliseconds. You can see the usage time is very low here. Now I do the same with curl. Everybody who does network programming knows libcurl. So basically do the same. It's a little bit more complicated. It's an old part of an old source code written like 10 years ago. So I'm not sure if curl has more features meanwhile. But what you do is you do an initialization. You set your options: curl easy set opt, curl easy set opt, curl easy set opt, and repeat this like 20 or 30 times. While in the libwget, you just have a list of options. Both approaches suffer from type unsafety, of course. Yeah, you do the perform and do everything, but you see curl took one round trip more for whatever reason. There could be some optimizations. Maybe we use false start, TLS false start as default or whatever. If you add up user and sys time, you are around twice as much as libwget does. Wow. And I think back, the libwget code is a little bit, well, smaller, a bit easier, but that's a matter of favor. Example 4, parsing URLs from HTML. So here you see the input. Can you see that? Yeah, the input. It's just a small HTML file. In the meta tag, you see the char set of this file is UTF-8. Well, I don't know if you do random downloads of websites, you sometimes have really nasty encodings, like Windows UTF-16, for example, with bombs and byte order marks in front to say if it's low Indian or big Indian, for example, and you have to care about this. There's a lot of details. Web pages are not just, or HTML pages are not just HTML pages. They can be in any char code or character encoding. So, yeah, but we care about this because wget needs to be ready for it. So, okay, the code here, as you can say, you have a certain type, HTML passed result, and parses the URLs inline. That means, well, you just get pointers to the places plus a length. This is to avoid, well, thousands of memory allocations per site. Sometimes we do like 10,000 sites per second on fast connections, and we don't want to have all this bloat. So, yeah, you also get the encoding. The meta tag has been parsed. Down below, you see the output. You see the printf encoding. It found UTF-8. It found, it's just a little loop around the past URIs. And we use our vector functions here. So it's like an array or a list, like you want. And we do this print out so you can see, oh, we have a link, href. There we found a test1.css or the image source set. It's an HTML5 feature, I guess. Well, is that pretty clear to parse an HTML file? You often need that in web clients, of course. Example 5, just something totally unrelated now, hashing. I talked about the crypto backends that we have, blah, 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 blah. I don't want to repeat this. We have the fast hashing, so we have a memory block, and you just say, okay, I want to have the SHA-256 hash of it. And here you go. we get hash fast. If it comes back with 0, you're done. It's, of course, in the binary form, but you have a function. It's commented here, wget mem to hex, just to convert it into hex. I see everywhere these small loops with sprintfs, percent 02x, for example. Yeah, you don't need this anymore. Fast convenience function. This is, well, this is an example of a convenience function that uses our internal hash function as well. Here you get, it's a combination of printf and you get a hex string back with your digest. Because this is a case that you often have. You don't want to have it in binary, you want to have it as hex string. And this is a part of the authentication thing in HTTP, just a little part, the H1 buffer. So you have to combine username, real password, separated by column, put it together, make a digest, and convert it to hex, because you need this hex string for further processing. So this function just does it in one. It's a very, yeah, in other cases also a very convenient function to make your application code shorter. While stream hashing is of course also possible, so we have for all kinds of digests, you have this typical init, where you get a handle and you can, like, you receive data, for example, packet by packet, and you can just put it in your, yeah, throw it into this hashing with this handle. Like, it doesn't cost you any wall time. It uses CPU time, of course, but you don't download something first and then build a hash. That can take very long. Like, imagine you have a 20 gigabyte files, which is pretty normal today with games or something. You first download everything, and then it takes ages to build a checksum. Now, you can do this with every packet that arrives. You have time before the next packet arrives, like whatever, 1 or 2 milliseconds maybe, but this is enough to continue hashing. So it doesn't cost you any time in the end. It makes you download and you're checking faster, if you need this. Example 6, TLS connection on a network layer. Not HTTP related. You can use this for, well, if you, what is it? POP3, for example, is also, there's a TLS version. There's, well, other, what do we have? Give me some examples. Where do we need TLS connections? Outside H.
Front-ends use TLS, for example.
Yeah, well, maybe more or less every protocol has a TLS version, even FTP, FTPS, for example. Anyways, you can build your own stuff if you just need TLS connection without caring or what kind of OpenSSL implementation do I use, have I everything in there. Hey, just use our code. It's very large behind the scenes, but it provides you with a simple API. Just an example, this is a TCP IP TLS connection. You do an init, then you can do some configuration. So you switch SSL, it's still called SSL here, it's TLS of course. Switch it on, switch host name checking on, this is a certain feature on the TLS SNI called server name indication, or just switch it on by setting the host. You can set, of course, a lot of other things as well. I don't go into details. Then you do a connect. Then you can do your write, read, or wait for the socket being ready for I/O. And when done, you just do a TCP close. And if you say, okay, I don't need this TCP handle anymore, you could do a second connection, of course, but if you don't want to do it, DINIT, and it's all resources are free. Well, decompressing. I added this yesterday evening after our talk was about LZIP. So yeah, currently the decompressing backends, we only have decompressing currently, but it would be, well, very trivial to build in the compressing stuff as well if somebody needs it. The decompressing, because an HTTP client always says, okay, I understand gzip or Z standard, and the server says, okay, here you go, and you have to decompress it. You never have to compress it. Well, maybe in post request, but we don't support it yet. Yeah, we have, of course, this typical content encoding gzip or deflate. Just for fun, I added bzip2, xz, and lzma. Then recently Broadly was finalized, and we have a Broadly library in almost every Linux distribution now. So we use that, BR, and Z standard. This is the compression standard made by Facebook, I believe. So, but it's coming. Z standard is even slightly better than Broadly. Yeah, what you do, you just open a decompressor with the whatever you want. We have an enumeration here, content encoding gzip or Z standard or whatever it is. Yeah, you have normally you have a string saying, okay, this is gzip. Then you say, okay, it's gzip. Then use this constant wget content encoding gzip. Open the decompressor. Now you can, yeah, you can go in a loop if you want. Decompress the gzip data plus the length. That's all. And as you can see, when you open it, we have a function. Oh yeah, I have it down below. Write data. This is a function that receives the uncompressed data. Whenever something is ready, the context is just a user provided variable that you can use then in this callback function. Data length. Well, you can print it to the screen or whatever. Return 0 says everything was okay, but if you want to stop all this, you can say return -1, return 1, whatever. Something except 0. Yeah, that's me just giving you some ideas. That's all. I don't want to go into the details now. I mean, of course, you can ask questions. The idea was to introduce this for a small workshop, so we can go into hacking sessions now, or into detailed questions. We have Darshit here, who knows everything about it. Well, more or less. We have Anda, who's a maintainer, who knows a lot. It's me, of course, and our Daniel is maybe come. Oh, comes in the evening. He's at university. Okay, so we are 3 people who can answer detailed questions, or we can even have a hacking session, like, well, we go through your source code, or we show you some more examples, or whatever you like. This is an offer. So, thank you very much. So, yeah, of course, if you have questions now, you can just go ahead, but
I confess I use wget, not get2, sorry.
Yes,
but
of course.
I have to switch now. If wget or wget2 stops for some reason, broken line, whatever, or communication or whatever, do you just type in the same command again and it restarts, right? You can restart it, wget2.
well, depends.
If you pass the -C switch to enable ring
Yeah, the server needs range header support.
Okay.
You're right. Not there are quite a few servers out there that don't support it. I don't know why. It's
Okay.
configurable on the server side.
Okay.
Some administrators maybe doesn't want it, but if the server provides that feature, you can continue downloading.
WC like continue.
Right.
Dash
Yeah.
C minus C like continue. Okay. Yeah.
Okay. But you say Daniel will come in the evening. He wanted to hold a talk, right?
We did talk, I think at the 6 p.m. slot.
Oh, at the 6 p.m. slot. Okay. We have a talk about wget 2 later. So if you have specific questions to command line options or how things work, I mean, we can answer this, of course, as right now, but maybe it's a good time later after that talk. Well,
A couple
Yeah.
of questions. You mentioned FTP in passing, but it wasn't actually on your list of supported download protocols. I presume I can download FTP.
no, wget 2 doesn't support FTP.
Oh, okay. Is there a
At a certain point, we said, well, FTP is a obsolete protocol, more or less. Sorry to say that. I know it's not true for everybody.
Yeah,
but
I mean,
it's-
there are good reasons not to use FTP, but there are certainly some
Yeah.
sites which are still only available with FTP.
Right. If you want to use FTP, we still support and maintain wget 1, the
Mhm.
old wget that supports FTP, but it likely won't go into wget 2,
Okay.
except someone comes and say, okay, I want to make a project out of it. Maybe we can have a second executable. Let's call it wget 2-FTP, just as an FTP client. Why not? You can use libwget and make it very easy. All you need is maybe a parser for directory listings, but we have it in wget 1, so we can just take the code out there. But just, I don't do this. I don't do this anymore. I don't want to go into FTP. I know it very well, but for me it's obsolete. But the offer is there if you want to add, well, an application for this small one around libwget. Feel free to do this. We put it into the repository then.
Okay.
Any more question?
Okay. Thank you very much.
Thank you.